Hello everybody, I'm Eli and I'm going to talk to you about my project that I worked on in semester 1 this year. So it was on the characteristics of Aureus Bacteraemia in Counties Manukau from the years 2011 to 2021. And I was fortunate enough to be supervised by Dr. Elaine Van Dell from the statistics department and also from Dr. Genevieve Wells, that is from the infectious diseases team at Middlemore Hospital. So firstly, I'll give a little bit of background on what these big long words mean. So firstly, Staphylococcus aureus. So it is a bacteria that probably about 20% of you in this room right now will be colonized with. It's probably most likely like in your nose or in your upper respiratory tract. But don't worry, completely innocuous, just sitting up there. It only becomes a really major problem if it is to get into your tissue or even worse within your bloodstream. When it's in your bloodstream, that's what we refer to as a bacteremia infection. And Staphylococcus aureus bacteremia, I'm just going to call it SAB for the rest of the talk because it's too long to keep saying, or SAB. It has a really high mortality, so depending on who you are, what comorbidities you have, it carries a mortality rate of about 15 to 30%. Really long length of stay in hospital, so places a massive burden on our already completely pressurised healthcare system, and it has some seriously inequitable outcomes as well. And within Aotearoa, New Zealand, we have some of the highest rates of SAB in the world, and within Counties Manukau, we have some of the highest rates within New Zealand, so it's a huge, huge problem for Counties Manukau. So from the year 2011 to 2021, the infectious diseases team at Middlemore Hospital collected every single SAB case over this period, which accounted for about 1,690 infections in 1,400 patients. So some patients actually got infected multiple times over the study period. And on each of these patients, we collected about 80 variables on them. So things from demographic information to what sort of treatment they got, what sort of outcomes, the source of the infection, and heaps more. We dealt with any problems with missing data using the multiple mutations technique with the MICE algorithm. We then worked closely in conjunction with the Middlemore Hospital clinicians to develop some causal diagrams to identify biasing paths in our regression models. And from these causal diagrams, we then constructed a range of different regression models based on what the clinicians were interested in. So there was 3 broad buckets that they were looking at. So there's incidence models, so that's how prevalent is this infection within the population each year, some characteristics of the infection, like whereabouts are people getting this deadly infectious disease and what antibiotics are the infection susceptible to, and then also looking at rates of mortality over the period. I'll briefly touch on a couple of aspects of the method before we go into results for the final 10 minutes. So firstly, on the topic of dealing with missing data, so within the study, all the models we were running were just different flavours of GLMs, mainly count regressions and multinomial models. And as many of you will know, if you're wanting to run a regression model, you need, for every observation, something recorded for the variables that you're interested in. You can't just have nothing there. Things don't work. So there's a few ways around this. There is what we call complete case analysis. So that's where if something's missing, you get rid of it. That is incredibly wasteful, especially when you don't have a lot of data, and also can introduce heaps of bias into your regression estimates depending on the mechanism that produced the missing data. A little bit better than complete case regression is using single imputation. So that's when we create a model for our missing variables and predict what the variable would have been based on values that we did record. The problem with this is that you can often underestimate the variance in your regression estimates because you don't account for the imputation model that created this data. You just go along and do your analysis and treat values that you imputed the same as values that you actually recorded. So multiple imputations allows you to account for this variability within your imputation model, because you essentially define, for each of your missing variables, you define like a joint conditional distribution, and you sample from that for each of your missing values multiple times. In this case, it's just 3, but in practice, normally people use 5, 10, 50, depending on how much computing power that you have. And then that gives you multiple complete data sets, and then you run your regression models on each of these complete data sets and pull these results together. And when you pull these results together, you allow to account for the variability within your imputation model. So you're correctly accounting for that as well. We also used causal diagrams to direct our models. So causal diagrams are incredibly useful because they allow you to explicitly state your hypothesis and assumptions around the mechanisms that were generating your data. So here, causal diagrams here, they're DAGs, they're directed acyclic graphs, where a arc from, say, node A to node B means that variable A has some causal effect on variable B. And here we kind of loosely define causality as if you could imagine a parallel world where all other variables remained exactly the same, but you could reach in and just change variable A, and then that leads to a change in variable B. You can also include unmeasured variables within your causal diagrams, because we know that with any analysis, there's some variables that are either too expensive to measure, hard to put numerical values on, and yeah, many reasons why you can't record everything. And then that allows you to say you're wanting to find out the effect of someone's age on how prevalent this SAB condition is. These graphs can tell you what variables you should and shouldn't include in your model to reduce the bias in your estimate of age on SAB incidence, for example. Now I'll spend the last 10 minutes talking about various flavours of results that we looked at. Can't get through everything, but I'll try to get some highlights. The highlights are actually lowlights because all the results are quite sad, but that's sometimes life. So Manamoa were primarily interested in, firstly they knew that case numbers were increasing from 2011 to 2021, but obviously population figures were also increasing. So they were wanting to work out, were the increasing cases, in line with population growth or not? And contrary to studies around the world and other studies in New Zealand, we sadly found that the rate of cases was increasing above population growth. So yeah, our favourite flavours of count regression gave us about a 5.5% annual SAB incidence growth, which when you look at it over a 10-year period is a pretty damning figure of 71.4% 10-yearly incidence growth, which is just completely not sustainable at all, and raised some big alarm bells. So after they get this kind of top level number, they were wanting to work out, well, where are these excess cases coming from? So within many infectious diseases, they can be classified based on where you kind of contracted the infection. So we've got community infections, so that's, say for example, you're out at work and you have a workplace accident where you break the skin barrier, and then you get some of this bacteria inside your skin barrier and then eventually into your bloodstream. That would be a community infection. A hospital-acquired infection, sometimes people call it nosocomial infection. It's when you present to the hospital for a reason other than SAB, and then while you're there you contract SAB, so you get sicker while you go to the hospital while receiving treatment. And these type of infections are kind of seen as especially problematic because they're kind of indicators of stress on the healthcare system, or kind of performance within the healthcare system, because you shouldn't be infecting more people when they're coming through. And so this is the number of healthcare associated infections over time. And we saw that each over the study period, we were looking at almost 10% year on year healthcare associated growth in these cases, which over a 10-year period was 154.1% growth. So that means if you were spending a night in hospital at Middlemore Hospital in 2021, the expected number of SAB infections you were getting is about 2.54 times what it would have been back in 2011. That was, again, depressing, sad news, but important to quantify. We then move into some of the inequitable outcomes that I was talking about. There's many different results I could use to share the inequitable outcomes of this infectious disease, but I'll look at it through the lens of hardship. So we recorded the NZ DEP quintile, which I think was started by a team down in Otago many years ago, and essentially it breaks up New Zealand into tiny little mesh blocks and asks questions on kind of their level of hardship, and then ranks them based on like a percentile system. So if you look down at this purple line, that represents the 20% least deprived parts of the New Zealand population. So like if you're like living in Herne Bay or something like that, you're probably in that purple line, whereas in that orange line, that's the 20% most deprived people in the population. And you don't need a magnifying glass to see how different that lower, like the people in the best 80% conditions compare to those in the worst 20% conditions. And we quantified that for those in deprivation quintile 5, so the worst 20% of people in hardship, they had a 339% higher incidence. So for each member of the population, you're getting 339% more infections compared to quintile 3. We use quintile 3 because that represents the middle of the distribution. So again, sad, not good results. Before I go to the next slide, who thinks that males get more infections than females? Or who thinks that females get more infections than males? Hands up for males. Yeah. If you thought there was more infections in males, you were correct. Around many different studies on SAB, the figures around about 1.5 times as many infections per person of the population within males. There's a few reasons that people speculate on this. So there's kind of occupational hazards. Some people talk about hygiene. Also, maybe health-seeking behaviour as well. Like maybe, I don't know. You can come up with your own theories. But what was interesting here is that, like, there's been lots and lots of surveys done on this comparison, is that the figures that we saw in our data is that the ratio of incidence between those with male sex and those with female sex was much higher than everywhere else in the world. So we were looking at kind of almost 2 times as many cases in males than in females, whereas all around the world it's around about 1.4 to 1.5 times approximately. So either, I don't know, our Kiwi men are doing more stupid stuff and getting more infections, or I don't know, there's lots of theories you can work through on this. I'll briefly touch on some mortality stuff while we've got time. So this was one interesting aspect of our data, is that, so if you look on the y-axis, we kept track of the all-cause 90-day mortality. So that means you get the infection and then were you alive after 90 days of getting the infection. So you see the Pākehā group, the midpoint of their interval was about 0.3, so about 30% passed within 90 days of the infection. And surprisingly, the Pacifica group was the lowest mortality rate. And this kind of bucked the trend of all the other analysis that we were looking at, because in all other models where we were looking through is that kind of particularly Māori and Pacifica groups always were faring worse. They have the highest rates per members of the population. But this kind of painted a different trend for the clinicians. So what we kind of speculated on, or other models suggested, is that within the population, Pākehā people are getting it much later in life when they've got far more comorbidities, whereas what we think is happening is that when Pacifica people are getting SAB, they're much younger, they're in their 30s and 40s, and a lot of them are dialysis patients. So dialysis patients, kind of when you have kidney or renal failure and you have to go into dialysis units 2-3 times a week, and you get an intravenous line put in to filter out your blood, and these lines can get infected if they're not handled in a sterile way. So we are seeing over time far more intravenous line infections through dialysis units, and that's what we think is happening, is that younger dialysis patients at a Pacifica are getting SAB. The good thing with getting an intravenous line infection is it's really easy. You can just remove the line, and that's the source of the infection. It's a lot easier to control. I've plenty more results to go through, but I might leave things and take some questions about where the project's going next and what sort of work's been happening. There's a table showing the same data from the previous slide. So mortality rate of about 30% in Pākehā. I think our all-case mortality rate was around 21% for the study. Questions on all that lovely information?
Thank you.
Hello.
Hi. There are several things I want to talk about. First is that your slideshow don't seem to include much in relation to different age group. For example, whether it affects young infant more, or elderly people, or middle-aged people. The other thing is that have you thought about conducting the vaccine trial related to that?
So we did run lots of models with different age groups, and you find, well, firstly, these data are only from those aged 15 and above.
Okay.
The younger patients were in Starship, which is Middlemore's Child Hospital, but what we tend to see is that it's a lot more common in older age groups than younger age groups, but there's many interactions, particularly with ethnicity. So those, depending on what ethnic group you're in, like for example, being a younger Pacifica person, you might have the same incidence as like an older Asian or Pākehā person, but it tends to, your risk tends to increase as life goes on. Another question about vaccine. There is no vaccine at the moment. There's just antibiotics. So there's 3 common strains that that SAB can take on. One of them is resistant to your common kind of methicillin, and can't remember the other one. So one of them's a lot more deadly than the other 2. And the problem that we're seeing is that, we ran some multinomial models to look at the proportion of these strains over time, and we're finding that the antibiotic resistant strain is becoming more and more common within hospital settings. It's spreading over time. That's kind of what antibiotic strains do, or resistant strains do. Anyone else? Hey.
What's the explanation behind the lower socioeconomic, the highly deprived people being more affected?
So there's quite a few explanations or suggestions. One is it tends to be more overcrowding in lower socioeconomic places. So with any infectious disease, more overcrowding, more susceptible to catching the disease. Also less sanitary conditions, like some of these places wouldn't have washing machines, they wouldn't have access to having proper clean clothes. There's potentially occupational differences as well, like you might be in higher risk, more unsanitary occupations. Also maybe just knowledge and access to healthcare, and also the quality of healthcare you might be getting. You have less money to spend on your health. So those are the main reasons I can think off the top of my head, yeah.
What was the interaction with the mentor from the hospital?
But
How often did you interact with the mentor, and how did they help? What was the whole process?
a lot, yeah. Like, I think we were probably working together almost every week, especially when, like, I don't come from an infectious disease background, and that's often what you're doing when you're a data scientist. You're just dumped somewhere and you have to, it's about learning how to find all the domain knowledge that's relevant to your data. That's half of the battle. But yeah, they were, I can't speak higher of how much support they gave me during the project. They're so good, yeah.
And what algorithm did you use for this research?
What average, sorry?
Like machine learning model or algorithms?
It was all generalized linear models. So for a lot of the incidence models, we were using Poisson regression, and often with an offset, so using like population count as an offset, and then also lots of multinomial models as well. So we were just using, I was using R and using, primarily just GLMs for this, yeah. And then for inference, we were using like non-parametric models, so using like sandwich variance estimation, and for generating confidence intervals and things like that.
Okay, cool.
Did they give you any outlook on how they would use the results?
Yeah, so there's 3 papers that we're working on at the moment, and I'm going to go give a talk for them next Tuesday as well, so this was good. I get to do the talk again next Tuesday. But I think they're mainly interested in the intravenous line work, because there's a suggestion that they changed policy in 2017 where they didn't have to check the lines as regularly, and that's looking like that's potentially caused a lot more infections. And also they're wanting to look more into the dialysis units, because it seems like there's more and more cases coming from dialysis units. But yeah, it's mainly just also quantifying, because there hadn't been a big survey like this done in a little bit, so it was good to get an update, and also to buck the trend of all the other previous papers were showing that incidence wasn't increasing, whereas here we're seeing that we're getting more cases over time. So I think there's definite interest in these results.
Was that the explanation behind the 20? There was a
if you just look at community cases, so cases within the community, if you just looked at the period from 2013 through to 2021, there was no evidence of an increasing rate. So what it was suggesting is that from 2013 we weren't getting any more cases from the community. The cases were coming from the hospital, and I think it was 2016 or 2017 where they did a policy change, and they're wanting to kind of look into that, but without showing you the plot of just the intravenous line infections. It's just going to get lost in the, because this is all infections, whereas that policy would only affect intravenous line infections. But you have to be careful not to just go digging, and because you'll always find something. Anyone else?
Okay, thank you.